Alright, so we're going to start talking about derivatives, and we're going to do derivatives like graphically first, and then we'll get into how to do them from an equation. But first, I'm going to go through like what the concept is, what it means. Derivative is just slope, but it's not the slope between 2 points. It's the slope at 1 point, which you're not really used to. So, for example, if I ask you to find the slope between there, it is recorded. It should be recorded. Where'd you go? Let's see. I forgot to zoom it in again.
Where'd you go?
Okay. I'm going to leave it here because if I zoom in, the writing gets weird. But so if I ask you to find the slope between, let's say, this point and this point, you could like draw a line there, and you can figure out like, okay, I went up this much and over this much. That's like algebra style slope, right? So here's 2 points, find the slope between them. It's like y2 minus y1 over x2 minus x1, or rise over rho. Slope at 1 point is a little different, and it's kind of hard on this graph. Let's say I'm just going to kind of zoom in. Let's say I got that, and I want to know the slope right there. So I'm saying the slope at 1 point. So this would be like you're going down the highway and it's winter and there's ice on the road and you're coming along, and right here you lose your grip on your car. And so the road keeps going this way, but you lost your grip, so now you go this way. That is a tangent line. And the slope of that is what the derivative tells us. So the story is Newton was like sitting around one day and trying to figure out how fast the Earth went around, like the velocity of the Earth going around the sun. And he accidentally he figured out if the sun stopped having a gravitational pull and the Earth just went off, it was like had nothing to go around, it was just like wandering through space. He found like the slope of that line, and then he was like, oh, this is coming. Just like found and just went crazy. But it's that idea of, okay, the slope at 1 point instead of the slope between 2 points. Does that make some sense? So now I'm going to back off, be like, well, the way we find the slope at 1 point is actually to find the slope at 2 points. But we bring those 2 points like really, really close together. So if I wanted to find the slope at that 1 point, would using this point and this point be a decent approximation? No. I mean, just an approximation. It's not bad, right? That's not, okay, so how can I make it better? Move the point closer, right? So if I slid this guy back here, now is that better? Yeah. So what you do, and we don't really do it, it's just kind of like how we think about it. You let the limit between those 2 points approach what? 0. The distance between those 2 points will approach 0. It'll never actually be 0, but they'll be like 0.000001 between the 2 points. So if I find the slope between those 2 points, because they're so close together, it's basically the slope at 1. That's the big jump from algebra to calculus. We're not working with 2 points anymore. It's technically 2 points, but we're saying, okay, find the slope at any 1 point. This surfboard guy is a good way to think about it too. If you're riding along the curve and you imagine a surfboard, that surfboard is the slope of your tangent line. So if I'm right at the top, can't get it perfect, but if I could get that, anyway, if I'm right here, and the Earth stopped revolving around the sun or something, or the surfboard, the slope of that tangent line is approximately 0. I couldn't get it perfect, but it's basically horizontal. You know what I'm saying? If I go like over here, Now my slope is positive or negative? Negative. So let's talk about this now too. There's a big difference between the word negative and the word decreasing. Is this slope positive or negative? Are the y values on this graph increasing or decreasing? Are the y values on this graph negative? But they're decreasing, right? So negative and decreasing are two different things. And that takes some people some time to wrap their minds around. My bank account could be negative but increasing if I were paying off debts, right? Or it could be positive. It is positive and decreasing as I pay for a bunch of stuff. Totally. So if I'm over here, I'll say I'm right there. Y values, positive or negative? So here's the...
Are you saying Y values or Y value?
I was saying Y values in this area, but I guess specifically Y values.
Because if you go up, then the Y values are positive.
Yeah, I meant close. So you're right. I should say Y
That's why I was
value.
confused.
So, right here. Oh, it's back here. Oh, sorry, Steven. You're going to see this. Because then it's too small for you to see it. Whoa. Talk to me about this.
Alright. Make your thing full screen. No, next to the X button. Yeah. Nope.
Is there next to the
Red X button in the top
square?
right corner. Top square. Right there. Yep. Now just hit Control plus.
Why couldn't I just hit that before?
Well, you can't, but then only if you're in that screen. So if you make it full screen, just make it full screen.
That's fine. It's good. Everything's fine. Oh, that didn't help you at all, did it?
Yeah, no, that's what you're saying. Full screen.
Right, but it's not centered in the screen.
But that's why you can move the thing.
Now use the arrow keys on the keyboard.
There's no slider bars on the bottom! Tell me again, I'm supposed to slide this?
If you zoom in more,
But now we're so close I can't even see anything. But now there's no slider bar! So back to where I was 2 minutes ago. Sorry, Steven. Right there. Y value. Positive or negative? Increasing or decreasing? The Y value is increasing, right? As I'm going along, the Y value is increasing.
So a Y value increasing is the same as having a positive slope.
And being below the axis. So the Y value negative means we're below the axis.
Yeah, I was just saying a Y value increasing.
That's what I'm trying to get at. Yeah. So okay. So now, so Y prime means derivative. That prime means derivative. It means we're going down a level. We're looking at slope now instead of the original graph. Y prime here, the derivative, the slope, is it positive or negative? It's positive. Just knowing that the derivative is positive, does that tell me anything about the Y value? No. It just means we're going up. So the Y value increasing is the same as Y prime being positive. That's a huge concept that I just said, which we'll practice over and over again. But the Y value increasing. So Y prime is just slope. The Y value increasing is the same as the slope being positive. Agree? Yep. If my line's going like this, what's my Y value doing? Increasing. What's my slope? Is my slope on my arm right now? Is my slope increasing?
No. Your Y
Slope is staying the same. My Y value is increasing, but is my slope getting bigger and bigger? Like the slope of my line might be like 1. Is that changing? No. So a lot of people will mess this up and try to tell me the slope here is increasing. You gotta be careful with the word increasing and the word positive. They mean two different things. Increasing means it's getting bigger. Positive means it's above 0. Those are two different things. Okay. Let me start moving this dude along the circle. And then, because eventually what we're going to get to is, can you graph the derivative? If I give you like the original equation, can you graph the derivative?
If you're only looking at one basic point, can you ever say that the slope is increasing or decreasing?
Yes, but you don't know how yet. So then we get into concavity, which is whether it's curving up or curving down. And we can find that at one point, but I don't expect you to be able to do that at this point. At this point, see what I did there? All right, so this graph down here on the bottom, can you guys see this? Like in the back, can you see it, Brandon? If you're good enough. The slope of this graph is represented on here as y values. So right here, this slope, positive or negative? It's pretty positive, right? It's pretty steep. So we have down here a relatively positive y value. So the slope of that is approximately 3.5. So when I read the y values down here, this represents the slope up here. So like, what's the slope right there? 0. Well, what's our y value down there? 0.
Excuse the interruption. All cheerleaders need to be released at this time.
Don't go anywhere.
Cheerleaders.
Don't go anywhere.
When I came out of your
I know something broke with it.
It's on the ground right now.
Everything's like still.
It's below the chair.
Mr. Davis.
Stop!
You need to be invited to the
Stop! I know I do. What's the slope? Right there.
1.5.
Like a little over 1? 1, 1.5, 1.2, somewhere around there, right? What's the slope right here? Oh, you can't even tell, sorry. What's the slope right here? Maybe a little bit under 1. Do you see what I'm doing? But like you understand, that's because it's too small, right? There's no sideways scroll bar. I don't know if you guys noticed that. Do you understand like the concept of what I'm okay? So then when we put this all together, like I can make a graph. We'll get into more of that in a couple days, but there used to be, hold on a second. There used to be a way to take that bottom thing off and then like move the surfer dude along. Hold on.
So the first derivative does slope. What is the second derivative?
Concavity. Tells you whether your slope is getting bigger or smaller. So I can change this to whatever, like if I make this x squared, let's say, then I could get my graph of the derivative there too. So here my slope is, okay, get out of the way, I know it's disconnected. My slope is negative, right? So I got a negative slope. My slope is actually getting a little bit bigger as we go, right? It's increasing. So that's why this line is going up. Here my slope is 0, so you can see the y value down at the bottom. This red dot is at 0. What's the slope right here? 2. You can see by the red dot helps, right? What's the slope right there? 3. What's your question? Yeah?
So if that was just the, like, if you look at just that tangent line.
This guy?
Yeah. If it was just like that, the same all the way, would the second graph just be a straight line?
That's a really good question. So let's say y equals 2x. That would be a line, right?
Yeah. Just like straight.
Why Why? Maybe that's be 2 times x. Yeah, okay. So what's the slope of this graph at every single spot? 2. So does that make sense why the bottom is just a horizontal line at 2? Let's go a step further than that then. What if I graphed y equals 2? What's the slope of y equals 2 everywhere? 0. So what's our derivative look like? Down just a horizontal line at 0. Down there. Good question. Anybody guess what the derivative of sine of x is? Cosine of x. This is sine up top, and then if you looked at the derivative and figured out what was what, it's cosine. Yeah. Actually, the derivative of cosine is negative sine, so it's a little different, but close enough. Okay. I know. So, today we're not going to start graphing those yet. We're going to back it up a little and start a little before that. So write this graph down in your notes. So let's say this is g of x. That is the original graph. That is g of x. I'm not going to have you graph g prime yet, but I'm going to ask you some questions about g prime. Even though we can't really see it yet. This is the part of the picture. Does she have an answer? Sorry, that wasn't like the easiest graph to copy down, I guess. I could have made that. Yeah, but it's like crooked. Sorry, well, looks like a crooked W.
Actually, it's a crooked F.
Oh, yeah, that makes more sense. She sits, reverse this. Is there a jacket under your desk? maybe?
Yes. My jacket.
Sorry.
Is there a jacket that's much too small for you?
Yeah.
I'm pretty sure actually you guys would be squishy. It smells so good.
Okay, so, shh. Zip it. So if I asked you to estimate, let's just start with, because now you got to be able to go back and forth between g and g prime. If I ask you to estimate g of -1, that's not calculus. That's not slope. That's not derivative. That's just like when the x value is -1, what's the y value? So estimate g of -1, and what do you get? I would say -1 because you're just right. When the x value is -1, your y. So maybe it's like -1.5 ish around there. Now let's say I said estimate g prime of -1, and there's a pretty big margin for error on these estimates. But you got to know what you're looking for. So g prime of -1 is I go to x equals -1 on the graph, and you kind of draw that surfboard. And then you estimate the slope of that surfboard. So, to me, this is going pretty darn close to like up 1/1. Agree? So I'm going to say the slope is 1. Really, it's like these approximation things. If you put 2, I think you're fine. If you put 0.5, I think you're fine. If you put 0, that's clearly wrong, right? Because what would 0 look like? Horizontal. And if I put negative, that'd be wrong, because what would negative look like? That would be going down, right? Alright, estimate g of 2. Estimate g prime of 3. G prime of 5.
0.
G of 2 is just the y value there. That's 0. It might be like negative 0.1. I didn't draw it very well, but G prime of 3, what's that?
3.
Slightly negative. Even if you put 0, I think I can handle it there. It's probably like negative 0.1 or something. Again, there's a room for error. If you put positive, I think I can reasonably mark you wrong, but it's definitely not sloping up. It's either flat or slightly negative. Fair? G prime of 5. So this needs to be a pretty positive number. Like that's steeper than this one was, right? So maybe 1.5 or 2-ish. I don't care about the precise number, neither does the AP test. Does it make sense what we're looking for?
Yeah, I just have a hard time
Drawing the surfboard?
Yeah.
Like it doesn't make sense how you're supposed to, or it's your artistic ability that's getting in the way?
No, it's like I don't know quite how to.
So imagine you're coming along here, you're on a road, all of a sudden you hit a patch of ice. You would go that way, right? Like you would keep going, you wouldn't take the curve, you would like keep going straight based on wherever you
That
were.
makes sense.
Okay. Alright, so the AP test would look more like this. I'm going to give you 3 things and I want you to put them in order from low to high. So you don't need to know the precise number. So let's say G of negative 2, G prime of negative 2, and G prime of 0. Low to high. That's a terrible question. No, wait, no, it's not. It's a genius question. I'm sorry. It took me a second to realize. So basically, one's going to be negative, one's going to be 0, one's going to be positive, and you're putting them in order. You got what?
So G at negative 2 is like negative 2.
Agreed.
Prime of G at negative 2 is 0.
Agreed.
And then G prime of
Yeah, G.
G of 0, yeah.
It's the exact same statement. It's like, wait,
It's hard to
So did you fix your?
It's hard to
you need it first.
Okay. Well, then that's the insult. True, false. I put it over thing.
True.
So I didn't mean to, but G prime of negative or G of negative 2 is negative something, right? Negative 2.5, let's say, so it's a negative number. G prime of negative 2 is pretty close to 0. Agreed? G prime of 0 is some sort of positive number, maybe about 1. So I actually had them in order low to high. I didn't mean to do that, but it just happened. How many had that correct? Okay. Let me go. I made 26 copies and I got back like 19. So if you have your homework, you can start. If you don't, sorry. I'll be back soon.
You know, all signs of key.
I don't know why. I'll be back soon.
Hey, Steven, who you be?
Are you serious? I left like
I'm leaving here around like
Stop.
yeah, because I'm gonna be over there after. So just make sure okay, I'm gonna leave and I want to go. Wait, tell me this eye. I was going to draw some big dogs and then jump to them. I know what this would take about 20 minutes, right? To get to the middle, like to get to the area of tower, grab your house, get back. It's
Can
different.
you actually answer my question?
Yeah, I said different. She was like, you should leave at 3:30, then I'm like, it's gonna take me a half hour to get to the middle school, get to McDonald's, and get back to the well, yeah, but I'm not gonna. I'm gonna go to the drive-thru. So, like, I just want to have a steady. Right. if I don't get to eat before the parade, it doesn't matter. I'm gonna still feel like a couple months. Yeah. Yeah. Me and my sister are gonna run through the drive. I describe homecoming. Here's my thought process. Yeah, but I mean, here's my thought process.
You're short
Parade, and then during the game, we're like, it's as the other than like,
T-Rex
right, see, like, no, like, I have to go to the park for my parents, because otherwise I would have never, ever, like, everything, like, emails, like, okay, do we need to say money Thursday? My parents know all I buy is steak. They give me like stock on like anything. That's all I use. All I was saying is, I don't know what it is. These are like, the thing is, like, I don't be like, I'm today, like, I'm really, like, I have to really McDonald's or not.
Sorry about that, guys.
It has it is very